boys and girls. My name is Andrea Berry with the Knox County Schools Science Department, and this is a third grade lesson in science. This is Activity 2 for the summer, and activities and handouts can be found in the Student Resource tab in Knox County Schools webpage. Show us what you've learned by tweeting at KCS Science. If you find this video hard to understand, turn on the closed captions, adjust the playback speed, consider watching short clips, or ask someone in your home to watch it with you. Stop frequently and talk with your partner about what you heard and understood. So let's get started. Today we're going to talk about a story about a little boy named Jeremiah, and he and his mom were fixing some macaroni for lunch. And Jeremiah was boiling some water, and as this water started to heat up, he noticed little bubbles starting to form. And then the bubbles became bigger. And he had a question. Here was his question. What's in the bubbles? So he wanted to ask some people from his home, what's in the bubbles? And as he thought about that question, he asked his dad. And his dad said, there are bubbles of heat. And then he asked his brother. His brother said, the bubbles are filled with water. And he asked his grandma. His grandma said, the bubbles are empty and there's nothing inside of them. Then he asked his mom. His mom said, the bubbles are an invisible form of water. So we have 4 people's opinion there. And I want you to think about which one do you think is right and why do you think they're right? Which one do you agree with and why do you agree with them? On your handout, you can see on the Activity 2 handout, Part 1, it gives Jeremiah's story, and then it tells you Dad, Caleb, Grandma, and Mom's opinion, and then there's a place for you to decide which family member is correct, and then a place at the bottom for you to draw what you think is happening. So pause the video at this time and do that portion of your handout. All right, before we can really decide who's right and how to answer that question, we need to back up and we need to remind ourselves what we learned about the states of matter. So let's review what you talked about in Activity 1 for science. Everything in the universe is made of matter, and it exists in different forms, which are called states. So we're going to talk about the 3 states of matter. Do you remember what they are? Do you remember one is a solid, one's a liquid, and one is a gas? So let's talk about each one of these. A solid, the particles are very small and close together, and they have a fixed shape and a fixed volume. Liquids have a fixed volume, but take the shape of any container that you pour it into. It's going to take the shape of a bowl, or a cup, or a bottle, or a pool. Then we have gases, and gases, the particles spread way far out. So we're going to take a second and we're going to put on our special glasses that help us see particles. Now normally we can't see any states of matter particles without having a super powerful microscope, if that. So we're going to put those on, we're going to put on our super powerful, and we're going to look at our slide here, and we're going to see that we see particles, and these particles behave in a certain way. And if I look at each container, I can figure out which state of matter, based on what I know, are those particles belong to. So take a second and think, which one's a liquid, gas, or solid? Did you say this first one was a solid? If you look, you can see it's a very fixed shape. Those particles don't seem to be flopping around or moving around anywhere. Did you say this one's a liquid? It's taking the shape of the container, and the particles kind of just move and settle wherever they're supposed to within that container. And the last one here is a gas. The particles seem to be as far away from each other as they possibly can be. So as we look, let's spend a little bit of time talking about a gas today. okay? So we're going to remind ourselves what those properties are. And I have a special simulation for you. And it's going to show you some gas particles, and I want you to notice how they behave. What do you see? Tell somebody in your home what you notice about them. Okay, so here I am. I'm putting some gas particles into our container. What are they doing? Watch them as they move. What did you notice? Did you notice they're trying to expand really far away, get away from each other, and get out? And then when they hit the side, they kind of bounce around, but they still don't want to touch each other? So, does gas take up space? We've seen how the particles move, and they seem to not want to touch each other. But does it take up space? That's something we need to know too. And we've got a really cool experiment today for you to do to figure out if gas takes up space. So, what you need for this experiment is a napkin or paper, a cup, and then some water that you can dunk the cup under. I suggest getting a small cup. It's pretty small, not a real tall one, because the smaller it is, the less water you need in your sink or in a bucket to put it fully under. So in your handout right now, you have part 2, and this is us asking the question, does gas take up space? So it tells you the materials you're going to need. I've already told you what those materials are. And before doing this experiment, you need to predict what you think is going to happen. And the question is the napkin going to get wet when we dunk it under the water? And then you're going to draw your thoughts in that box and label the parts of what you think is going to happen. But before you do that, I want you to watch this portion of the video so you can see how to do this experiment. Okay, let's watch closely. And as we look at him, he's shoving that down tight. And the key is to get it down real tight so it doesn't flop out easily. It's like he's flipping it over and it won't come out. And then he's going to take that short cup and then he's going to put it under the water. That's what's next. And that's how he's going to do it. Look, straight on under the water for a few seconds. And he's going to hold it there for a few seconds. So that's what he's going to do. So I want you to go back and think about, what are your thoughts here? Do you think the paper napkin will get wet? Yes or no? Pause the video and see what you think. So then it will tell you exactly the steps to do the experiment, but I've already shown you through the video. And then it gives you a place for you to draw a model about what happened. So the first box you drew in should have said what you think was going to happen. This box is what actually happened. This experiment is really fun and kind of cool, but I'm going to show you the video of what happens if you don't get a chance to do it at home. So let's watch and see what happens. He's already got it under the water. Now he's lifting it up. Oh my goodness. What do we see happening? Is it going to be wet or dry? It's dry. Oh my goodness. So how did that happen? Well, when the glass was lowered into the water, the air is trapped inside. It didn't tilt. You notice if you tilt it and put it in the water, the bubbles come up and lets the air out. But that glass wasn't actually empty. It had the paper in it and it had some air in it. The air is trying to get out. But when you flip it over on top of the water, you capture some of the air. And as you push it down under the water, guess what? It's going to trap some of that air. And that air protected the paper or napkin from getting wet. So air takes up space. We know it takes up space now. This proved it. So our answer is yes, it does take up space. So it got me wondering about other bubbles I've seen before. I love to blow bubbles. I love to see the bubbles. The bigger the better. And I started thinking about how these bubbles move. These are huge bubbles that I found to show you. But look at how they move. They move the particles inside of those bubbles are air. They're trying to expand out. And watch what happens as those bubbles kind of, it popped. So were the bubbles empty? Well, let's look at this right here. What happens when you need to make a bubble? What is she doing? She's blowing air into the bubble. So we know inside this bubble is air. So the states of matter we see here is we actually see, and I don't know if you've seen liquid bubble soap that you dunk in your little, wand, so we'll call it that, and you pull it out and then you blow through it. So the liquids, that's liquid soap, that's a liquid. And then when you blow the air through it, the bubble has air on the inside and that's liquid around on the outside. So sometimes I have some friends at home that blow bubbles, and when they pop, it gets the floor wet. That's because the liquid is dropping to the floor and the air that was inside expanded out. So, knowing what we know, let's now look at part 3, because we've got a lot of evidence to take to part 3. After watching this video lesson, which you've watched a lot of it so far, and doing some of the experiments you've gotten to do, revisit the story about Jeremiah at the beginning boiling the water. Do you remember what his question was? His question was, what was inside the bubbles? What is in the bubbles? And so who do you think is correct now? I want you to think through those answers, and we're going to look at them in just a second. Think about who's correct now. Did your thinking change? Do you think somebody else could be right? And why did you change your thinking? Maybe there was something I said today or that we did today made you think the way you're thinking. So I want you to write the name down, and then in the why portion, please go ahead and write a sentence saying why you've changed your thinking. Sorry. So here we are. We're back to our big problem is what is in the bubbles. And here's what our family said. The dad said the bubbles are in the heat. Caleb said the bubbles are filled with water. Grandma said the bubbles are empty and there's nothing inside of them. And the mom said the bubbles are an invisible form of water. So here's who we know is not right. Caleb is not right. The bubbles are filled with water is what he said. And that's not the case. The bubbles wouldn't be there if it was all water. It would all just be water. There wouldn't be any bubbles. The next one is Grandma. She's not right either. Grandma, the bubbles are empty and there's nothing inside of it. We know that matter takes up space, and so something is taking up space in there. We just don't know what it is yet. And so that one's not correct either. And there's something we need to think about here, is that heat is being added to this water, and it's heating up. And so let's think about Dad's answer, which was, it's hard to see right there, but he says the bubbles are heat bubbles, that they're filled with heat. Well, heat is not a state of matter. Heat is not matter. Heat is energy. So you can heat matter up, but heat itself can't fill the bubble. So guess what? Dad's not right. So who was right? Oh my goodness, it was Mom. The bubbles are an invisible form of water is what she said. That's kind of tricky, an invisible form of water. Air is invisible. Air is a gas. There's lots of gases in the air. So let's think about what Mom said, what was happening here. So it's in the water were bubbles, and that is in water vapor, a gaseous form of the water that is not visible. It's unlike steam, which contains some water liquid. When water's heated, the energy supplied to that system is increased and makes those particles move faster. So those liquid particles that we saw at the beginning, they start moving faster when there's heat, okay? And they have so much energy they can no longer be loosely connected, sliding past one another. So the energy now allows them to have those be overcome by this invisible gas, in which is the form of water vapor. And so inside the bubbles were actually water vapor, and since they're lighter than the water itself, they start to bubble up because they're trying to get out, they're trying to expand. So, what was inside the bubbles? It was a gas, yes. So, we've already talked about the question, does gas take up space? And we have lots of evidence for that. Yes, we know it does. It took up space inside the bubbles. And so now you're going to go onto your handout and it says, what evidence from the video helps support the claim that gas takes up space? So what did we learn today that helps support that we know gas takes up space? Let's go over that really quick. First, we talked about seeing the bubbles in the boiling water. And now we know that is gas. Then we actually did an experiment where we saw air being trapped inside the cup. And while it compressed and it got smaller, it definitely protected and took up space in that cup when it went underwater and protected the paper napkin. And then the last thing we saw was when we think about bubbles, we were thinking about the bubbles that you blow. That too has air and takes up space inside of it. Because the more air, the bigger the bubble is going to be. So we've learned a lot about gas today. Let's look at those particles again and see what we see. If I put some gas inside of here, what are we going to see? They're constantly moving freely in all directions. There's so much space between the particles. They're not stacked neatly together. They're not laying close and sliding over each other like liquid. They do not have a fixed shape. They're trapped inside of this container, but they don't have a fixed shape. Pretty neat, huh? Thank you for joining us today on our lesson on matter, specifically about gas, and learning what was in those bubbles. I'm Andrea Berry with the Science Department. Again, feel free to tweet us your findings and all the neat things that you're doing in science this summer. And thank you so much for joining us today, and have a great summer and a lot of fun. Thanks for learning with us.